Alright class, today we're going to talk about another type of conic sections, and this is hyperbolas. And we're going to start with 2 points, which we call the foci. And by definition, if you remember from what we did last time in the computer lab, this is a hyperbola where you have broken into 2 pieces, and every point on this line has some type of relationship between the 2 foci. So let's take a look. If I take the distance of this point, P to F1 and P to F2, we see here we have some distances. So from P to F1 and P to F2, these are the 2 different distances. And from P2 to F1 and P2 to F2, these are the distances. And as you can see, they change as the points move on the hyperbola. But what does not change? What stays the same no matter where I move the points to on the hyperbola? And that's not the sum, but the difference. So if I were to take the difference between these 2, the positive difference is 7, and the positive difference for this one is 7 as well. No matter how often I change the points, it still maintains that relationship. So the difference between a hyperbola and an ellipse is that in a hyperbola, the sum of the differences of the distances are constant, whereas in an ellipse, the sum of the distances are constant. So let's take a look at some important components of a hyperbola besides the foci. And it's important that you've taken the notes or print out the notes and have them with you, because we also go over them in depth in the notes. So let's take a look here at the segments and the differences. And as you can see, even though this changes, it stays the same. This differences stay the same, as you can see here. So a hyperbola has a major axis, but instead of calling it a major axis, we call it a transverse axis. And like in an ellipse, the transverse axis goes through the 2 foci points, as we can see here. And then if we were to take the distance between the 2 foci point and find the center point, we have the center of the hyperbola. And then if a line is perpendicular to the transverse axis and goes through the center, we call it the conjugate axis. So unlike an ellipse, which uses major axis and minor axis, in a hyperbola we use transverse axis and conjugate axis. And like an ellipse, we have vertices of the parabola, and those vertices are found where the transverse axis intersects the hyperbola. And so this is vertex 1, this is vertex 2. Okay? So I know that's a lot of information, and then as a result, different from a parabola or a ellipse or a circle, is a hyperbola is broken up into 2 pieces, and we call these 2 pieces branches. So we have a left branch or a right branch. But like an ellipse, a hyperbola can be both vertical or horizontal based off of the location of the foci point. So if I wanted to, I can go ahead and change the position of the foci and make this from a horizontal hyperbola to a vertical hyperbola. So I'm going to basically change F1 and F2 to something like this. And now let's see what the hyperbola looks like. And as you can see, the differences between the 2 are still the same number. The difference between the distances are still 1.35. And here is negative 1.35 because now F2 is larger than F1. But we still have our transverse axis, which is no longer horizontal but more so vertical. And we still have our center point and our conjugate axes and our vertices. But now they're a little bit different because we have a different position of the foci. And as I move the foci farther away from each other, the hyperbola gets larger. Oops. Or if I move it, as I move the hyperbola, the foci points closer together, the hyperbola kind of bends more. Okay? All right. So let's take a look at the notes that are on page 33. I have a picture of exactly that. And as you can see here, we have an added terminology called asymptotes. And you guys may remember the asymptotes from earlier on with rational functions where there are lines that the graph will not cross. And the hyperbolas have two asymptotes, as you can see here. And they intersect at the center. And so on page 133 is where you have notes regarding those asymptotes. So this is a general form of the equation of a hyperbola. Notice the main difference between that and an ellipse is that instead of a plus, we have a subtraction symbol. So that lets you know that we're dealing with a hyperbola and not an ellipse. And we can say that the ellipse is a the hyperbola is a horizontal hyperbola if the larger number a is underneath the x. So that means that we now have a horizontal hyperbola, and the vertices are going to be on that axis. In this case, since the origin is at 0, they're going to be on the x-axis. And if we have the larger number being underneath the y, then the vertices are going to be on the vertical axis, which is the y-axis. But one of the things I want to note is it's no longer always x first. Now we have, because of subtraction, we have the larger part first. So instead of just x squared minus y squared, it's going to be whatever the larger part is. So since it's vertical, it's y squared minus x squared. So now the question is, where does the a and b come into play? So let's go back to our graph. So I want to point out, since now the foci are in a vertical format, now the transverse axis is right there and the conjugate axis is right here. So what else occurs? We're going to remove the branches. We're going to clean up this a little. And we look at this difference between the distances, and we see it's the number 3.2, whether positive or negative. So that tells me that 2a is going to be either positive or negative 3.20. And if we take a look at a, then that means a has to be half of that, which is 1.6. So our a is 1.60. And then we also have another value called with relationship to the center, which is the distance between the center and the foci. So let's take a look here. So as we can see here, the distance between the center point and foci 1 is 2.85, and the distance between the center point and the foci 2 is 2.85. We're going to let that distance be c. So we have a is equal to 1.60 and c is equal to 2.85. So what would happen if we would square these two and take the difference? Well, we get this number. And what would happen if we take the square root of that? Well, we get this number. And so we're going to let b be equal to that. So we have our a and our b that are part of our hyperbola function equation, and they're formed by this relationship. B squared is equal to c squared minus a squared, and that's how we're able to figure out these two. Now in your notes it says that a squared plus b squared is equal to c squared, and that's perfectly fine. It means the exact same thing. But that's where the a and the b come from. A comes from the distance, half the distance between the difference distance, and then c comes from the distance between the foci and the hyperbola, and so you can calculate b from both those numbers. So let's take a look at an example. As we go along, please fill in the correct answers because it's not like that in your notes. So here I have a conic section, and they want me to identify the vertices, foci, and asymptotes of the hyperbola. I know it's a hyperbola because it has that subtraction symbol. So when I make sure that the right side is equal to 1, in order to do that, I have to divide both sides by 324. So when I do that, I get y squared minus 9 minus x squared over 36 is equal to 1. Well, that lets me know that since my larger number, since y squared is first, that means a squared is equal to 9. And since x squared is second, that means b squared is equal to 36. So that means a is equal to 3 and b is equal to 6. Since the y squared term is the positive of the first term, that means the transverse axis is vertical, not because a is bigger or smaller, but because y squared is first, which is a little bit different than when in an ellipse. And I have to correct myself. And the vertices are of the form 0, positive 3, 0, negative 3. Now how do I find the foci? So we know that c squared is equal to a squared plus b squared. And since a squared is 9 and b squared is 36, we get 45. So c is equal to the square root of 45. And that number is around close to 7. 6.7. So that means my foci, which are also on the vertical axis, are at 0, square root of 45, or 0, negative square root of 45. Okay? And the asymptotes, because it is a vertical hyperbola, we can write the asymptotes as plus or minus a over b. And that's how we get, since a is 3 and b is 6, 3 over 6, which simplifies to 1/2. So we have these two axes. To draw the hyperbola, we can there's a method that we can do as well, but we'll go over it in class too. But in essence, you're going to draw a rectangle centered at the origin that has a height of 6 units and a length of 12 units, because of a is 3 and b is 6. And then the asymptotes will pass through those corners of the rectangle. So let's take a look here. And here is the result. As we can see, here's our rectangle. The asymptotes cross through here. Here is our vertices. Here's our foci. And that's the ellipse. All right, I don't want to make this video too long, so I'm going to end it. But try and do the other exercises on the page 132. Thanks.